Hello, my name is Heike and I'm a project manager at the Werner-von-Siemens Center for Industry and Science. Werner-von-Siemens Center is an association based in Siemensstadt Square, Berlin. We want to connect industrial companies, research institutions, small and medium-sized enterprises, as well as startups, and enable them to form a consortium and implement research projects in the area of production change, mobility change, and also energy change. These research projects in an industrial context also take place in our laboratory space. We have various areas in the shop floor, and the labs can be used for projects and the construction of demonstrators, and you can also find various machines here. For example, in this area, we have a cold spray machine where 3D parts can be printed from different materials. And over there, we have lathes and milling machines. They are also involved in projects in the field of production change and digitalization. If you look closely, you will find antennas all over the hall near the ceilings. These are, for example, antennas for the 5G network. Over there is a workbench, and we have here crane systems, and a forklift is moving materials in the storage area. In this industrial environment, we can be a real laboratory for a variety of industrial projects. The project that I supervise at WVSC is called 5G Compass. This is about a convergent access network that integrates 5G, LiFi, what is live communication, and also Wi-Fi. In that project, a total of 4 demonstrators are being set up in the areas of medicine, home, office, and finally industry. In this demonstrator, I would like to show you more about today. The part of the WVSC is providing the industrial environment and the necessary equipment for the project. Also, we ensure the safety on the shop floor. Further, we accompany the implementation phase and the testing.
I want to give you an overview over our use cases we want to present. For the convergent access network developed by the 5G Compass project team, we developed 2 use cases in our industrial hall. The first use case deals with a scenario with a forklift that needs to be teleoperated in a narrow, filled-up high-rack storage area. In that area, it should move a pallet from one place to another. For automated operation, this task is difficult to accomplish. Manual operation in the traditional mode, on the other hand, is costly and unflexible. Instead, one operator should be able to move several vehicles from a teleoperator place using cameras and Lidar. These sensors generate a lot of data needed for the teleoperator to have a detailed view of the vehicle and its environment. To provide the required wireless network capacity, we use light communication in that area. So now my colleague Vinesh from Teraki will explain more about it.
Hi all, I'm Vignesh Selvaraj. I work as a product manager in Teraki. Teraki specializes in the development of software development kits for sensor data pre-processing. By this, we address the challenges in the development of smarter and efficient autonomous mobility. For example, I'm managing a product called T-Video, which enables vehicles to operate in semi-autonomous mode or the teleoperator mode. In the 5G Compass project, the vehicle we have is a forklift. This project is very interesting for us because we deploy our product in advanced upcoming network technologies like LiFi. Technically, the cameras in the forklift captures the surroundings and stream through this network to the teleoperator, and the teleoperator views this video in the teleoperator screen and sends back the input in the same network through trackpad and joystick to control the forklift. The forklift setup consists of high speed advanced computational unit equipped with a 5G router for network connection and a ROS to CAN module to communicate with the forklift's drivetrain. In addition to this setup, we also have 2D lidars which can detect obstacles and bring the forklift to stop automatically when the teleoperator fails to notice an obstacle in the surrounding. Also, as an additional safety and security measure, we have a wireless remote controlled emergency function implemented, which the safety officer on the floor can bring it to halt when the communication between the teleoperator and the safety officer is not synchronized properly. Now I will take you to the teleoperator area and explain things that are on that side. Please follow me. So this is the teleoperator area. Here is my colleague Kaushik. He is acting as a teleoperator now, and the teleoperator PC is connected to the same network where the forklift is connected, and it is also equipped with the trackpad and the joystick. And here you see the teleoperator screen where the surroundings of the forklift are displayed as a video, and now my colleague will show you how this is operated. So now you see the forklift is being moved with the control in front of my colleague. Thank you, Kaushik. I will now take you to the forklift bay area and we can see it in action. So now you will see the forklift in action when it is controlled by my colleague. Yeah, that was it. Thank you so much.
Before we meet Thorsten with the moderation of Ali, I would like to introduce more of LiFi with the explanation of Christoph from Heinrich Hertz Institute.
Hello, Christoph.
Hello, Heike.
Nice to have you here today from HHI. And we want to talk about LiFi. So what is LiFi?
Yeah, LiFi is a wireless communication system using light. With light, we can transmit huge amount of data. It's done simply by turning the light on and off very fast. Today's system can do this around 100 million times per second, so we achieve very high data rate and capacities.
And if you talk about high data rates, sounds amazing. Which range we are talking really about?
Yeah, today there are some commercial systems already available which achieve up to 100 Mbit. Our prototype systems from HHI can go to 1 gigabit currently, and in our laboratory we are working on the next generation of LiFi systems going up to 10 gigabit per second.
Oh, and how reliable is the transmission?
Yeah, to have a LiFi transmission, you need a line of sight between the transmitter and the receiver. And if you put an object or your hand, let's say your hand in between, the connection breaks and you lose the transmission. However, you can easily avoid this by using not a single access point in the ceiling, but multiple access points. And with it, your mobile unit always has a connection to at least one access point in the ceiling. And even if you block another one, you have still an active link.
Okay, and so that functions also when a mobile transceiver on an AGV is moving around and there comes an obstacle or shadowing something?
Yeah, exactly, yeah. If there's shadow from, let's say, a bridge in your industrial hall, it's not a problem since the AGV has another connection to another access point in the ceiling.
One further question. Is Li-Fi an affordable technology?
Yeah, currently it's more like a prototype system. But if we go into the mass market, like for example with Wi-Fi routers, we expect roughly the same price range. Mm-hmm. And it's also much less expensive than 5G.
And finally, could you say a few words how Li-Fi fit into an existing production environment?
Yeah, we imagine a Li-Fi as a supplement technology for radio. So for radio, like 5G or Wi-Fi, you can achieve very good coverage in a, for example, production hall. And with Li-Fi, we imagine that we have Li-Fi areas, for example, around machines, where we have a very high capacity, or we can use Li-Fi in areas where we have, for example, electromagnetic interference, which will disturb radio. Here we can use Li-Fi to still have a reliable connection.
Mm-hmm. Thank you. And is it easy to deploy? How you can take this?
Yeah, it's quite easy to deploy. You just have to put your access points on the ceiling, connect it to your building network, and for your AGV, for example, you put a mobile unit on top of it, and that's it.
Mm-hmm. And how you would integrate Li-Fi into an existing network, like we have it here in the Werner-von-Siemens Center. We have already 5G and Wi-Fi.
Yes, it depends on the application you want to cover. So the access point on the ceiling, as mentioned, would be connected to the building network with an Ethernet, for example. There are other approaches like using power line communication. Yeah, that's it. That's all.
Okay, great. Thank you.
The second use case addresses challenges that arise when a fleet of autonomous mobile robots is operated. The robots perform their task controlled by an external fleet management system, but in busy crossing areas, there could be accumulations of the vehicles requiring additional coordination in order to avoid traffic jams. Moreover, for important missions, certain robots may be granted higher priority. Other robots then have to clear the way and let them pass through. Because of the high data rates required for the real-time motion control in such scenarios, an intersection area in our hall is also equipped with Li-Fi transmitters, and data traffic handover from 5G to Li-Fi is automatically executed when the robots enter the area, and back to 5G at exit.
Now I want to introduce my colleague Ali. He will give you more information about the functions of the demonstrator.
Hi, my name is Ali Reza Ranjbar. I'm the IT manager here in Werner-von-Siemens Center and responsible for some of the IT infrastructure, architecture, and tests that we need for projects like 5G Compass. In general, for technologies like 5G, like let's say compared to a housing environment or an office environment, the industry always asks for a very different set of requirements. And this is exactly what we focus on here in Siemensstadt Berlin, where we have an industrial complex and basically have a particular focus for industrial mobile robotics. For these mobile robots, in the context of Industry 4.0, there's always a significant amount of sensory data that involves the streamlined operations. And while the industry always has very, very strict requirements in terms of safety and reliability, these robots also need very highly performing networks to fully accomplish their potentials. This is exactly what we basically address in this project, especially with the advancement of AI, to make the most out of edge and cloud computing methods. This project is also not entirely focused on 5G, but rather a convergent network access that with Li-Fi and Wi-Fi 7 together play a complementary role. And this would be something that my colleague from T-Systems, Thorsten Egenhoff, can now give you a more elaborate description. Hi, Thorsten. Hi. Maybe you could tell us a bit about your contribution within the 5G Compass project from T-Systems point of view, and describe the technology to us a bit, please.
Yes, sure. So in the 5G Compass project, we are engaged with our development around the autonomous logistics product that we are building here at Berlin-based Werner-von-Siemens Center. This is building also a foundation for the demonstrator in the industry use case for the 5G Compass project. What we are building is a fleet management system for operating a fleet of mobile robots that we also see here in the environment. So all the autonomous mobile robots are equipped with lots of sensor because they need to perceive their environment, to move autonomously here, to navigate across the environment and to be controlled. So this sensor data is uploaded to an edge cloud that we provide also to in the course of 5G Compass project. So with some services of the autonomous logistics platform, and the sensor data is then computed, processed, and also commands are sent back to the robots to have the navigation control. For this control loop, like sensor data and processing, we need high bandwidth at a very low latency to safely operate the fleet, so that they can detect obstacles, move around, or stop immediately if something is in its way. So this rely on a very good network. So this must be high performance network with coverage indoors, as well as for some use cases outdoors. But in the 5G Compass project, we have the we have a strong network focus to improve here for combining 5G with Wi-Fi and LiFi as a new technology in this context.
Now let me introduce you to the crossing scenario. In the crossing scenario, several cloud-controlled AMRs drive through the crossing area at the same time. Here we use the three AMRs Discussion, March and Snowball. To avoid collisions and to safely pass through the intersection area, the AMRs controlled by the fleet management overarching coordination strategies, such as right before left and right-hand driving rule, are implemented for all three AMRs. The intelligent control is based on the sensor data sent by the robots. In order to transmit additional sensor data from the AMRs in the intersection area, we have set up a LiFi network in addition to 5G and equipped the AMRs with mobile LiFi transceivers. We call this area a data shower because optical data transmission via LiFi enables increased data rates with low latency. To use the data shower, the handover between the 5G network and the LiFi network must take place when entering and leaving the crossing area. The decision for the type of connectivity is made by the so-called multipass technology based on the continuous performance measurements. The AMRs use the convergent access network for coordinated passage through the intersection area in the scenario.
Thank you very much for the elaboration from your side.
Now our little tour through the test field here at WVSC and through the thematic landscape of the 5G Compass project comes to an end. I hope we have been able to give you an impression of the possible applications of a convergent access network in industrial production and also shed some light on the associated innovative technologies such as 5G, Wi-Fi and LiFi, edge computing, autonomous mobile roboting and the teleoperated industrial trucks. But there are certainly still many unanswered questions. Please feel free to contact us, for example using the contact details shown here.